Alright, so now let's take a look at standard form. So the top ones we knew that they were going to turn into slope-intercept form. Now we're going to look at standard form. If you remember standard form was the ones that we would say like x and y were on the same side. So there's something plus something and then it equals some constant c. Oftentimes in this the c value is our total, like our final amount, whatever a and b add up to. And we're going to use this form, unlike the other form where we look for the word per. In this form, we're going to look for kind of context clues that talks about two different objects being kind of related to each other, where there's two different, not necessarily even related to each other, there's just two different objects all together that are being combined. So like pens and pencils, or boots and coats, where they talk about like two different things. And they're trying to relate those two different things to maybe a total cost. And whenever there's two different things, that's where we're going to try to write things in standard form. We just have to figure out what our two things are, and that's what will make our x and y. So let's take a look at this problem. It says Sam ordered 2 hamburgers and 3 hot dogs from the concession stand at the baseball game. His bill came to $19.05. And so when I look at that, the process we want to go through is, oh, okay, it's relating two different things. It's talking about hamburgers and it's talking about hot dogs, and it's coming to a total. And so whenever they're relating two different things and it comes to a total, that's probably going to be something that we might be able to model with linear standard form equations. And so what I would do is I would just define what my x is going to be and what my y is going to be. And so I might say that my x is going to stand for the hamburgers, or the cost of the hamburgers in this case. And the y is going to stand for the other object, hot dogs. And it doesn't have to be hamburgers and hot dogs. It just has to be two different types of things. It could be pens and pencils, or books and movies. Whatever it happens to be, as long as there's two things that are kind of related and they total up to a total, then we're going to be looking at it. I think these are one of the easier ones to write, because you just have to talk about how many of each you have, or what relationship they are, how much money they are. And so this, it says 2 hamburgers. So instead of hamburgers just being x, I have 2 of those hamburgers. We've talked about the word and being a symbol for plus. Oftentimes these are added. It can be subtracted, but oftentimes they're added. 2x plus 3 hot dogs, so plus 3y, because the hot dogs were our y. So 2 hamburgers, 2x, and 3 hot dogs, so 3y. And then they have to equal the total. And so in this case, the total is going to come to a total of $19.05. And so this is our, if it says if hamburgers cost $5.25 each, write and solve a linear equation. So just like last time, there's 2 parts to this. There's a writing part and a solving part. The writing of the equation we're already done with. This is the equation that models that situation. If I think about what x and y mean, it's just like saying, hey, I have 2 hamburgers and I have 3 hot dogs, and I paid for them, and it totaled to be equal to $19.05. It says write and solve an equation to find the cost of each hot dog. So I'm going to be looking at what y is, the cost of the hot dog. Now, the only way I can find out what y is if they told me what the cost of a hamburger is. So I look back and say, yep, sure enough, they told me what the cost of a hamburger is, so I can plug that number in for x. And so instead of writing 2 times x, I know how much my hamburger costs. I had 2 hamburgers at the cost of $5.25 each. So if I want to find the total cost of the hamburgers, I would do 2 times x, or 2 times $5.25, plus my 3y. I still don't know the cost of a hot dog, so I'm going to keep it y. And that equals my total of $19.05. And now I'm just going to solve for the cost of that hot dog. If there's math I can do, I always do the math. So I can do 2 times $5.25. $5 twice is $10. 25 cents twice is 50 cents. So I know 2 times $5.25 is $10.50. Plus 3y equals that $19.05. Now we're just solving for y. Y is not by itself. We have some things to undo. I'm going to have to undo a times 3. I could divide everything by 3 first, but it's going to be easier to get rid of farthest away. So let's get rid of this $10.50 because it is a positive $10.50. We'll subtract it from both sides. So this is just basic solving 2-step equations, something you guys are pretty good at. That's going to cancel out. It gives me 3y equals $19.05 subtract $10.50. If I grabbed a calculator, probably would need to do that. It would be $8.55. And then I just divide by the 3 to figure out what the cost of the hot dog. If I take $8.55 and divide by 3, you get an answer of $2.85. So I know that each hot dog costs $2.85. So now I've written the equation and I've solved it. The biggest takeaway on this is just that it didn't tell me per, like these equations told me per something, so I knew to write it in y equals mx plus b. This doesn't tell me per, instead it relates two different objects, hamburgers and hot dogs, and so I'm going to try to write it in standard form. It can get a little tricky. Not all of them are tricky, some of them are really straightforward. The other ones aren't necessarily tricky, you just have to think about how they relate to each other. And so I wanted to skip number 6, let you guys try 6, and I wanted you to look at 7, just because I think 7's interesting. Now, normally you wouldn't know what type of problem this is going into it. You would have to read it to figure it out. We know these are standard forms, so that gives us an advantage. But let's see if we can read number 7 and figure out why we can tell it's standard form. What in there tells us we're relating two different objects. So it says Karen's piggy bank has all dimes and quarters. And so I'm already thinking, dimes and quarters, but it could relate in different ways. But there's two things getting related, dimes and quarters. So I'm going to just keep reading just to see. The total value, all right, so anytime it says total, again, I'm thinking, total value of the money in her piggy bank is $11.40. And so I have something that relates dimes and quarters to a total. And so this is where I'm thinking this is probably going to be standard form. So I'm going to say, all right, well, X is dimes. You could also make Y dimes. That's just whatever was written first is what I usually make X. Quarters is Y. And again, you could have switched that around and you could call it D and Q. It doesn't necessarily matter, but we'll just use X and Y. But then we have to find some kind of relationship. Like last time it said there was 2 hot dogs, or 2 hamburgers and 3 hot dogs. So it was easy to say 2X and 3Y. But in here it doesn't say like 10 dimes and 20 quarters. It says if she had 36 quarters, so I could say, okay, I know it's 36 quarters, but it never tells me how many dimes. So I got to be careful not to use the 36 as part of the equation. I think that's part of what is going to help me solve the problem. Instead, because it totals up to money, I have to think about, well, what is the worth of these in money? And that becomes my relationship. Until you practice a few of these and see a few of these, it's really easy to kind of miss that idea that, wait a minute, I know how much a dime is worth. It's worth 10 cents, and I can write 10 cents as 0.10x. And I can figure out how much quarters are worth. They're worth 25 cents. 25 cents written as a dollar would be 0.25y. So I'd say like I get 10 cents for every dime and 25 cents for every quarter, and then I total the $11.40. And again, nowhere in there does it say 0.10 or 0.25. This is where I would have to know that a dime is worth 10 cents. Oops, that's not a cents. And that a quarter is worth 25 cents. And then use my prior knowledge to set up the equation. So that tells me to write and solve an equation. So here's my written equation. So I did the first part. And now I'm just left to solve it. I'm supposed to be solving to find the number of dimes. I know the number of quarters. I know my quarters, it's Y. I know I'm going to have 36 quarters. It wants me to find how many dimes. So I'm basically going to be solving for X. To solve for X, I'm going to have to plug in a number for Y. So I'm going to start this over, and it's going to be 0.10x plus 0.25 times Y. Now I know what my Y value is. It says I have 36 quarters. So I have 36 quarters that are worth 25 cents each. When I'm all done, I'm supposed to have $11.40. And so if you think about this, not necessarily even algebraically, you just think of it common sense-wise, oh, I have 36 quarters. Well, I can figure out how much money that's worth. I could do 0.25 times 36 on my calculator. Or I could think of, well, I know 4 quarters is $1. So every 4 of these is $1, and I can get 9 sets of 4 out of this. So 36 quarters is going to be $9. So just in quarters, I have $9. In the end, I'm supposed to have $11.40. And so that 0.10, that must be the remaining money. It's just my dimes. So my dimes plus the money worth of quarters equals my total. And so I just copied that down. I did the 0.25 times 36. I get the 9. And now I'm solving for X. Farthest away is the 9, so if I subtract 9 from both sides, if I subtract 9 from this, I get $2.40. When I have $2.40, I'm going to divide that by the 10 cents each one is, or divide by the 0.10, and I get a value of 24. So I'm saying that I have 24 dimes, 36 quarters, and that's how I get to the total of $11.40. But yeah, sometimes you're going to have to kind of do that inference. The rest of these, I think it tells you what each one's worth. But if you want to try 6 and 8, those would be great to try. If you have questions, of course, let me know. We're just working on slope intercept form and standard form today. We'll work on the other types come next week.